Did NVIDIA just make this robot too accessible? Today on AI News, we're breaking down the three massive hardware layers powering a brand new open reference platform from NVIDIA, Unitree, and Sharpa to see if this is finally the blueprint that changes everything, starting with its brain. Because NVIDIA just announced the Isaac GR00T reference humanoid robot platform for academic research, and it's aiming to finally unify advanced AI with physical hardware. In fact, this open architecture uses Unitree's H2 Plus chassis paired with two SharpaWave hands for its physical body. But before we get into those, first, the robot's brain is powered by an onboard NVIDIA Jetson AGX Thor T5000, and it features an NVIDIA Blackwell architecture GPU that processes real-time inputs from a multi-view sensing suite. And for perception, the system relies on a head-mounted humanoid binocular camera with a wide field of view, alongside optional ultra-wide-angle wrist cameras for close-range manipulation tracking. And the accompanying software stack provides a complete end-to-end development loop. On top of this, NVIDIA's Isaac Teleop captures human demonstration data, which then feeds its Isaac GR00T open foundation models to train complex, multitask behaviors. From there, training and evaluation are performed within the Isaac Sim and Isaac Lab simulation environments, which allow the accelerated NVIDIA Isaac ROS middleware to deploy the learned policies directly to the physical hardware. And by providing both an open hardware and software blueprint, this initiative completely eliminates the black box limitations of proprietary systems. But the core component of NVIDIA's new reference architecture is actually the SharpaWave tactile 5-fingered hand, with each weighing just 1.3 kilograms or 2.8 pounds, and each providing 22 active degrees of freedom to bring the combined GR00T system to a total of 75 degrees of freedom across the entire chassis and limbs. And in terms of power, it handles a mechanical structure payload of 30 kilograms or 66 pounds, while maintaining a fingertip force of 20 newtons and a total grip force of 150 newtons. And for sensory perception, it's driven by a dynamic tactile array, with each fingertip containing over 1,000 embedded tactile sensors. This localized data is managed by a neural network-based sensing algorithm, which is capable of a force detection range spanning from 0 to 30 newtons, alongside a sensitivity threshold of just 0.005 newtons. And finally, there's Unitree's H2 Plus, which acts as the full body to support it all. Standing approximately 182 centimeters or 6 feet tall and weighing nearly 70 kilograms or about 150 pounds, it features a quick-release lithium battery, with the H2 Plus body incorporating 31 degrees of freedom configured as 6 degrees of freedom per leg, 7 degrees of freedom per arm, 3 degrees of freedom in the waist, 2 degrees of freedom in the head, and when combined with both of its 22 degree of freedom hands, the H2 Plus packs a total of 75 degrees of freedom throughout its entire body. And as for its physical power, the robot produces a maximum arm joint peak torque of 120 Newton meters and a leg joint peak torque of 360 Newton meters, enabling a continuous arm payload of up to 15 pounds or 7 kilograms, or a max lifting capacity of 33 pounds or 15 kilograms. And as for its battery power, the H2 Plus packs a 75.6 volt smart battery with a 15 amp hour capacity, which is almost 1 kilowatt hour, providing up to 3 hours of operation, while its base hardware runs on dual onboard Intel Core i5 and i7 processors. And Unitree is planning to start manufacturing and selling of the H2 Plus by late 2026. And while no official pricing exists yet for the H2 Plus, the H2 on the other hand currently ranges between $29,000 and $68,900. So tell us in the comments how much you think this H2 Plus should cost. But NVIDIA is also redefining how AI perceives reality, as they just dropped Cosmos 3, a massive new family of open-weight, omnimodal world foundation models built specifically to give physical AI systems common sense. Because up until now, robots had to use separate AI models to listen, read instructions, process vision, and calculate motor outputs. But Cosmos 3 completely obliterates that fragmented approach by instead unifying text, images, video, audio, and physical action sequences into a single massive mixture of transformers architecture. And this isn't just a basic video generator, it's a full-scale world simulator that links perception directly to physical execution. In fact, Cosmos 3 establishes a brand new state-of-the-art across both understanding and physical generation, with third-party benchmarkers like Artificial Analysis already ranking it as the #1 open-source text-to-image and image-to-video model on the market, while RoboArena ranked it as the best active policy model for robotics. And on top of this, Cosmos 3 allows a robot to fluidly switch between vision-language reasoning, forward and inverse dynamics, and robot policy execution. For example, you can feed the model a single string of text or an input video, and the system can accurately predict the trajectory needed to perform a complex physical task, all without needing any pre-programmed coordinates. And to completely democratize this tech, NVIDIA also released the code, the model weights for their Cosmos 3 Super and Cosmos 3 Nano models, and even their proprietary synthetic datasets. So by providing the open physical body with the Groot platform and the ultimate omnimodal brain with Cosmos 3, NVIDIA is effectively giving any developer on Earth the keys to state-of-the-art humanoid intelligence. But their push to make AI accessible isn't just happening in robotics labs, it's also coming to a new generation of desktops and laptops, as NVIDIA and Microsoft just announced NVIDIA's RTX Spark at Computex, which is a new consumer system-on-a-chip designed to run local AI agents. So instead of relying on a standard processor, this physical hardware integrates a 20-core ARM CPU co-designed with MediaTek, a Blackwell architecture GPU with 6,144 CUDA cores and 5th-generation tensor cores, and up to 128 gigabytes of unified memory. And the architecture delivers 1 petaflop of local AI compute, allowing users to run 120 billion parameter language models completely offline with up to a 1 million token context window. And during this announcement, Jetson Huang stated that computing is shifting away from traditional application clicking toward localized AI agents that execute tasks via natural language. And to secure these workflows, Microsoft and NVIDIA built native Windows security primitives alongside a new NVIDIA OpenShell runtime, where the framework sandboxes open-source agents like OpenClaw and Hermes Agent, allowing them to manage local files, execute cross-application workflows, or process high-resolution video pipelines, all without sending data to cloud servers. And don't forget to hype, like, and subscribe, as well as click on this video here to see more of the latest in AI and robotics news.